All right, so yesterday we learned all about tangent lines. So please remember that a tangent line, quick review, is a line that crosses a circle. Crosses a circle at exactly one point. So like right here, this would be a tangent line here. And then please remember that it forms with the radius a 90-degree angle. Okay. Today we're going to talk about chords and arcs. So a little different than a tangent is a chord. And a chord is a segment whose endpoints are on the circle. So in this example here, this right here would be a radius. This is the radius. This right here is what we call a chord because both endpoints are on the circle. Okay. Once again, this right here is a chord because both endpoints are on a circle. So you can see how it's a little different than a tangent line, but chords also have special relationships that we're going to talk about. So within a circle, congruent central angles have congruent arcs. So we call it a central angle if it crosses through the center of the circle. So basically what this says is that if this measure right here is 30 degrees, then the arc is also 30 degrees. And then you could say the same thing on this side. This would also be 30 degrees, and the arc from C to D would also be 30 degrees. So again, a central angle, the arc, so the angle is what's got a vertex. The arc is the segment of the circle. So this is what we call the arc. And in a circle, all the arcs add up to 360 degrees. So there's a total of 360 degrees. So this segment here is 30 degrees of the 360 degrees. So the rest of the circle, this whole arc over here, would be 360 minus the 30 degrees that's right there. So that would be a 330 degree arc. Okay. So we know that central angles are congruent to their arc. So what do I mean by that? I know that if this central angle, because it crosses through the center of the circle, is 61 degrees, then this arc right here is also 61 degrees. And please also remember that a diameter, so this diameter right here, is going to cut this arc into 180 degrees. And then the full circle, all the way around the circle, is 360 degrees. So a couple little vocabulary terms. If the arc is greater than 180 degrees, then we call it a major arc. If it's less than 180 degrees, we call it a minor arc. So you might see that vocabulary used. All right, so we want to find GBC. So GBC is this angle right here. That's the what we want to find. All right, so we know that this is 65 degrees, which means we can also indicate that this angle over here, because they're vertical angles, this is also going to be 65 degrees. Okay, and now what you should notice is that this this part right here is 180. So if you do 180 minus 65, you get 115 degrees, and that is this angle right here. So the answer is 115 degrees. Now, would that be considered a major arc or a minor arc? Well, it would be a minor arc. So let's just go ahead and do number 2 as well. So first of all, I'm going to indicate that this is my diameter, okay? Diameter cuts a circle in half. And then if I know that this is 43 degrees and I know that this is 67, that means I know that this is 43 and this same central angle is 67. And so I want KIM. So KIM is this part right here. So first I had to figure out this part, right? And so I'm going to do 67 plus 43 is 110. And then I'm going to take 180 minus 110. And that gives me 70. So that's 70 degrees. So now I want these two together, this arc here. So that's 70 plus 43, which is 113 degrees. Okay? So you want to finish the rest of this page to number, and then on the back side to number 12. So please remember that either you're finding the arc or you're finding the angle measure, the central angle. They're equivalent to each other. They're congruent to each other if the vertex is in the center. Okay, a couple more information that we need to know about chords is that if a chord intersects a diameter at a perpendicular degree, at a perpendicular angle, then they also bisect each other. So this chord here is intersecting this diameter and they're making a 90-degree angle, then I can say that this segment and this segment are congruent. And that's just repeated throughout this, okay? You can also say that they make a 90-degree angle. So if I say, like in this example here, that this chord is intersecting the diameter and that this is congruent to this, then you know that they're going to also make a 90-degree angle. So it's vice versa. And because it goes to the diameter, you can say for certain that it's going to go through the center of the circle. Okay, so these are some rules that somebody proved a long time ago. And now let's go ahead and apply them. So first of all, we know that radius is half the diameter, and the diameter is twice the radius. So d equals 2 times r, and r equals 1/2 times d. Okay, and then we know that the Pythagorean theorem, which is a squared plus b squared equals c squared, is used to find missing lengths in right angles. So we want to find the length of the segment indicated. Well, first thing I see here is this is considered a radius. And this is also considered a radius because a radius is half of a diameter. So if these are both radiuses, x is going to equal 9. Okay, and here's what I was talking about. This right here is actually, if you extend this line, this is what we call the diameter. And this is a chord because it has two segments. And I'm saying that this is crossing at a perpendicular angle, so I know that this is perpendicular bisector. So that means that x is also going to be 12 because those two segments are going to be congruent to each other. So again, it's just applying the rule that we know that we just learned about. Okay, let's do a couple more examples and hopefully this will get easier for you. All right, well, first of all, we know that this is the radius. The diameter is 28.8. So that means that the radius is 28.8, the radius, divided by 2, which is 14.4. Okay. And then I know that this is a chord, and this is a perpendicular bisector. So I know that this side is equivalent to this side. So this is 12.2. Okay. So now I have, this is my C, and this is A, and this is B. So I can set a Pythagorean theorem, but I'm going to use the inverse of the Pythagorean theorem. So 14.4 squared minus 12.2 squared equals B squared. Type that into your calculator and you get B squared is equal to 58.52. Now I take the square root, and that's how I get B equals 7.6, which is correct. That's the answer that I got. So there's a lot of information that I had to know to figure out the missing information. All right, let's look at this example, number 18. So when we look at this, I see that this is a chord, okay, and it's being intersected at a perpendicular line with this right here, okay? So if this is 9.5, I'm sorry, let me redo this. This is not the chord I'm looking for. This is a chord, is a diameter, and this is a radius. I'm sorry, this is a radius, and this is a diameter, and it's being cut by a chord, so this is 9.5, this is also going to be 9.5. So those are equivalent to each other. Okay, number 19 is very similar to number 17, but I want to know the whole diameter. This whole piece right here. So this diameter is cutting this chord. So this is 15.4, so this is 15.4 as well. Okay, so now I know that I can find c squared. So this is c here. This is b. This is a. It doesn't matter. So I'm going to do 15.4 squared plus 10.4 squared. And that's going to give me c squared, which, no, that's just the radius. So this gives me, when I work this out, and then I take the square root, I get 18.5. So this part right here is 18.5, but this part as well is 18.5 because it's two radiuses. So if you put them together, you get 37.2. Okay. Here you'll notice that this has been marked as a perpendicular bisector. So therefore I know that this is also going to be congruent to this because this also makes a perpendicular line. So if this is 13.6, this is also 13.6. And so this is exactly like the problem before. So I'm going to find this side right here, which is c. So it's 13.6 squared plus 7.9 squared. And that'll give me c squared. So when I work this out, I got c squared is equal to 247.37. Then I take the square root of that. And that's where I got c equal to 15.7. So c is 15.7, and then I got to add on another 15.7. So 15.7 times 2 is 31.6. Or something close to it. All right, so you should now be able to finish all the way to number 24, and then you want to check your answers to make sure that you are correct. The answers are going to be posted on Canvas, so you can go back. Please ask questions if you have any questions. But before I answer any questions, I'm going to be looking to see that you have completed and taken notes on the lesson.